All right. So if we consider from the previous cases that we had on our calculus, we managed to focus the gradient concept that you be given as the average gradient, average speed, and also considering some applications of the limits. We are going to need to understand also the standard forms and the rules that can be used in our differentiation. So what is it that we are considering in this differentiation that we've been talking about all this while? If you are given a certain function of y which is equal to f of x, we saw that we can apply the limits to find the first derivative from the first principles. So it follows that there are presentations that we can use to present a derivative. Y is equal to f of x, y is equal to x squared plus 2x, whatever that you're given. We can present or indicate the following symbols to represent our differentiation. So we can use the concept of dy with respect to x. We can use the dx concept to represent a derivative with respect to x of whatever that you are given there. We can present this as the first derivative with respect to x. All these formats can be used to differentiate a certain term, expression that you are given under our derivatives. So it is always a general or a basic rule that you are going to need, that whenever y is given as an, or let's just say ax to the exponent of n, because we must write this in terms of x. Therefore, the derivative of this y with respect to x, which is our dx, which is our first derivative, or you can write this as d dx of that f of x that you are given there, whatever that part that you're given. How are we going to differentiate? How are we going to find the first derivative of this? All right. So we drop the exponent here to multiply the number that you're given. The exponent, it multiplies the number, then you subtract a 1. It's a rule that you're supposed to follow. So it's equal to an x to the exponent of n minus 1. So on this rule, what we need to consider is the x has to be raised to a certain power. This is not 1 over x. This is not 2 over x, 2 over x, no. It's x to an exponent. So any can be positive, any can be negative on any condition that you be given. So this is what I'm trying to say. Let's say you are given y is equal to 2x to the exponent of 3. And you're asked to determine the derivative of y with respect to x, or d dx of what you're given. So from this concept, you multiply these two, you subtract, so you're going to have the product of these two terms. So you multiply these two terms, the 2 and the 3. So that is simply 2 times 3, just like that. Then the part of x, we are going to subtract 1 on the exponent. So it's going to be x to the exponent of 3 minus 1, any minus 1. So you multiply, you subtract 1. That's the rule. Multiply, subtract 1. So it means this will be 2 times 3, which is 6x to the exponent of 3 minus 1, which is 2. So it gives us a direct derivative. A direct derivative. All right. We had this from the first principles concept. If you still remember, y is equal to x squared, where we got 2x. We want to see, is it what we are going to obtain this time? There is a number that we are given there, which is a 1. So you're going to multiply 2 and 1. 2 times 1, that is 2. X to the exponent of, you subtract 1 on the exponent. So that's 2 minus 1, which is a 1. And that is simply 2x. And if we check from the first principles, when we differentiated y is equal to x squared from those limits, we obtained a 2x. This is to show us that we are having the same answer, but there we are not using the first principles concept. No, we are using the rules that can, the rule of our differentiation. As long we can have this in this format, we can differentiate it in this way. So it also follows that in some standards that you are given some other forms of presentation, if you are given y is equal to ax, A is a constant, guys. Just like for an example, you are given, for an example, this is e.g. we've got y is equal to 7x, y is equal to negative 3x. As long this is just x, not x to the power of just x like this, raised to the power of 1. Do not worry on this part. Once you find the derivative of such, you are going to simply remain with a. So meaning to say, if I'm given a 7x like this, the derivative of y with respect to x is just going to be the constant, which is 7. The derivative of y with respect to x on this is just going to be a negative 3, which is the constant. So the first format that you need to know, which is referred to as a linear. So this is a linear term, just like when you're dealing with those linear functions, y is equal to mx plus c. So even if we are given that, just going to take our a as our gradient. Then the second part is when we are given this to be equivalent to a constant. Y is equal to a. We do not have x here, so it means this is a constant. Y is equal to a constant. For an example, y is equal to 3, y is equal to 2, y is equal to 7, y is equal to a. It's not in terms of x, it's just an a like that. It means a is now a constant. Y is equal to b. There is no x there. Whenever you have such a condition where y is equivalent to a constant, a number, the derivative of y with respect to x in that condition is a 0. Meaning to say, if I'm given y is equal to 3, the derivative there is a 0, a 0, a 0. All these constants, the derivative will be equal to a 0. So I'm not going to waste much time on that. So now that we do understand these derivatives, a constant, a linear, and a normal part of our basic rule that we are given there, we are going to see that in most cases, they are not going to give us just like single terms, like what you're given, y is equal to 3x, differentiate dy dx is going to be equal to 3, because we are having the format of the ax, so y is the derivative must be equal to a. They are going to give us questions as expressions. So you'll be given to give the derivative of given terms or expressions where they are being combined. They are now expressions. You're asked to find the derivative with respect to x, or determine dy dx, given that y is equal to, let's say I've got 2x to the exponent of 4 minus 3x plus a 7. So when you are given different terms combined on a single expression like what we have here, we are going to find the derivative of each constant, of each term that you are given there. You determine the derivative of each term. So given a condition that we are finding the derivative with respect to x of f of x plus or minus gx. These are two functions that we are given there. It simply means we are going to find the derivative with respect to x of f of x on its own. We are also going to determine the derivative of the gx on its own again. The derivative of this gx on its own, provided we are following the sign that is given there. So you find the derivative of each. So this simply means there are 3 terms, 1, 2, 3. We find the derivative of each. That is the concept of this part. You find the derivative of each term. So in actual sense, it means we're supposed to do it this way. To find the derivative of y with respect to x, you differentiate this with respect to x. Remember, we're going to use our basic rule. Whenever you've got an exponent, drop the exponent, subtract 1. So in this case, you drop this exponent, then subtract 1. So that's 4 times 2, which is 8. X to the exponent 4 minus 1, which is 3. Minus 3x, this is a linear term, just like what we had, a linear term. Ax is going to give us a, which is the coefficient of x, which is negative 3. 7 is a constant, just like a, so the derivative of a constant gives us what? A 0. So it was supposed to be plus a 0, which means there is nothing there. Just like that. So just have the basic format, the rules to be used. You must have the basic format. Determine the derivative of y with respect to x. You are given any format of an expression that you have. Let's say we have got y is equal to 7x squared minus 5. We're going to find the derivative of y with respect to x. Multiply this. 7 times 2, that will be 14. X, we subtract 1 here, so it's just going to be 1. Minus 5, 5 is a constant, so the derivative of a constant, that's a 0. So meaning to say our answer is just going to be 14x, just like that. So it's just a basic derivative that you just need to follow. So they will just try to confuse you. They will give you brackets. They will give you these terms that you need to simplify in a format that is the to rewrite in the form of ax to the exponent of n. They will just try to confuse you with any condition that you might be given in any situation that you have. So in this case, we want to determine the derivatives or to differentiate with respect to x. Differentiate with respect to x. With respect to x. So whatever that you are given is with respect to x. So let's say we are given y, just a question like they can just give us something like 20x to the exponent of 4. You're asked to differentiate with respect to x. It's up to you, the format, the way that you're going to write. So in this case, we are going to have the derivative with respect to x of 20x to the exponent of 4. All right, so let's see what we're going to have. The derivative with respect to x of this, we are going to multiply this, then we subtract 1. So 4 multiplies 20. 4 times 20, that is 80. X to the exponent of 4 minus 1, which is a 3. You're done. We could have written this as d dx, the derivative with respect to x of 20x to the exponent of 4, which is still going to be the same thing. It's a format. Or we can let this to be equal to y. Let y be equal to 20x to the exponent of 4. So meaning to say we can determine as dy dx. Still the same way. We can write this as f of x is equal to 20x to the exponent of 4. So on answering is going to be the first derivative if you write this format, 80x to the exponent of 3. Still, these are presentations whenever you are just asked to differentiate with respect to x and it's not given as y is equal. They just give you a certain term or a certain expression you're going to write in any one of those formats. First derivative, dy dx, dx, d dx, d over dx. It's up to you. The way that you are going to present there, it's actually up to you. All right, so like I said, we've got different questions to consider. Let's say we are given minus 2x minus 5x squared. So meaning to say the derivative with respect to x of this expression that you're given, negative 2x, negative 5x squared. Remember, we said whenever a condition of this is applicable, we differentiate every term that is inside of the bracket. Derivative with respect to x, derivative with respect to x of the other function. So in this case, we're going to differentiate minus 2x. Minus 2x follows what? The concept of the ax. Remember, ax is a linear term, so you're going to have a. So this will give us a negative 2. Minus 5x squared, there's a power there to consider, so you drop that power to multiply a 5. Negative 5 times 2, that's negative 10x then we subtract 1 on the power. So 2 minus 1, that's a 1. So meaning to say, this is simply -2, -10x. So we have determined the derivative, or we have just differentiated with respect to x, which we can choose, let y be equal to this, then you find dy, dx, this and that. So given terms, guys, we're just going to differentiate like that. Each and every part that you're given. There you are given terms, you are given fractions, they can just try to manipulate you guys. It's still one and the same thing. The derivative with respect to x of this, we're just going to drop the exponent. So this is -1/2 x squared. So drop the exponent to multiply there. That means we're going to have a -half times a 2. X to the exponent of what? We subtract a 1 on the exponent. So that's a 2. So half of 2, that's a -1. X, which is simply equal to -x. Okay, -1x, guys, is simply -x. So that's it. We can differentiate terms, whether they are fractional terms, they are brackets that you are given to differentiate with respect to x. Then you have got 3x minus 1 into x plus 1. So how can we differentiate this? We can just have this as the derivative with respect to x of what? There we are given 3x minus 1 into x plus 1. So in this case, when given brackets or terms like we have x into a certain bracket, expand the brackets first so that you can clearly see the terms separated. So the first thing, we need to remove the brackets. That is to expand the brackets. Okay, we are not differentiating, we are still to differentiate. So this can be written as expand your brackets, 3x times x. That will be 3x squared. Remember how you expand your brackets, 3x and 1. That is going to be plus 3x minus 1 multiplies x. That is going to be minus x. Minus 1 multiplies a 1. That is going to be a -1. So this is it. We can simplify again, 3x squared. We've got like terms here. 3 minus 1. Take note here is just like there is a 1 there. So it's 3 minus 1, which is 2. So there we've got a 2x minus 1 like this. This expression can be differentiated direct from the rules and the standard forms that we are seeing there. So let's differentiate. So the first part, we're going to differentiate this term, 3 times 2, which is 6x. Remember, you subtract 1, so it's going to be 6x. A linear term, 2x, is going to give us a 2. Minus 1 is a constant, so that's a 0 there, meaning to say we do not have anything left out there. So it's just going to be 6x plus 2. So that is the derivative with respect to x. Sometimes you need to expand the brackets that you are given. You need to expand those brackets. Sometimes factorization has to be, it depends with what you're given. Sometimes you need to apply the factorization concept, expansion of brackets. It depends. So whether we are given with respect to x and this is given as dx like this, and we have got something like this, x plus 2 squared. Expand brackets. So you're going to have the concept there. Remember the concept of a plus b squared. Guys, in short, we do understand that a plus b squared is equal to a squared plus 2ab plus b squared. So there's a plus, so it's going to have dx, expand brackets. So this will be x squared, the first term. 2 times a times b, that's 2 times x times a 2. So 2 times 2, that will be 4x. So meaning to say we're going to have 4x in place of 2ab plus b squared. Our b is the last term, that is 2 squared, which is a 4. So that's plus a 4. So there we are just expanding our brackets. Yes, we can just open 2 brackets if you are used to that. This is same as x plus 2 into x plus 2. You expand as usual. Guys, you are used to that. You can expand. After that, differentiate. Each term with respect to x. X squared, drop the power there to multiply. There's a 1, so it's 2 times 1, which is 2x. Remember, you subtract 1, so it's just going to be 2x. 4x, that's a linear, so that will be plus 4. 4 is a constant, that's a 0 there. So meaning to say we are just going to remain with 2x plus 4. So like I said, questions might be given differently. The format, the presentation that you have, sometimes we need to even factorize, like for an example, you're given, let's say y is equal to x cubed minus 27 over x minus 3. And there you're asked to determine or to find dy dx. Very complicated situation that we have. But look closely, x cubed minus 27. This can be factorized from our sum and difference of two cubes. Remember, from your sum and difference of two cubes, if you are given this as a cubed minus b cubed like this will give us a minus b in one bracket. Then we're going to have the bracket of a squared plus ab plus b squared. All right. Why am I talking about this? This is the presentation of the x cubed minus 27. It can seem to be a complicated situation, but look here. This is x cubed minus 27. Remember, 27 is same as 3 cubed, 3 to the exponent of 3. So it simply tells us we have a, we also have b. So that is a and b. So from our formula, we are supposed to have a minus b. A minus b, that's x minus 3. So that's x minus 3 into a squared. Our a, which is x, is just going to be x squared plus ab, that is the product of a and b plus ab, x times 3, which is 3x. That's our ab. So this is going to be 3x plus b squared, which is the last term squared, which is 3 squared. So 3 squared is 9. So this is the format, guys. Also, you're given this from your formula sheet. So you need to understand that. So as we sum, this 27 that the x cubed minus 27 that we are seeing there, it is giving us 2 brackets x minus 3 into x squared plus 3x plus 9 into x squared plus 3x plus 9 like this. Everything over what? Over x minus 3. We are still simplifying. We are not yet determining the derivative. This is just a simplification. We are still simplifying here. We are still simplifying. So as you can see in this simplification, these two are the same. They can cancel, and thus remaining with x squared plus 3x plus 9, which is something that you can differentiate now with respect to x. We can differentiate. That will be a 2x. Remember this part, you drop the power, subtract 1. There we've got a linear, so that's going to check a 3. That is a constant. Its derivative will be a 0. So there's nothing there to consider. Just like that. So that is our derivative of y with respect to x. But just look what we had. A complicated situation that just needed to be factorized. So do you know your cubic functions? It can be x cubed plus 27, meaning to say we use the same concept. It can be like that. Then here they will divide over x plus 3. So you're still going to use the same concept. Remember, on this factorization or this part of a, which is the difference of two cubes. When there is a sum of two cubes, that will be a plus b into the bracket of a squared minus ab plus b squared. So know your expansion as well. How to expand this is important. So these are the typical questions that we might have under our derivatives. And sometimes you're just given those square root, this and that, where you just need to simplify. But that's the major part, guys. Maybe you're given 1 over x squared plus maybe this is the square root of x. Whatever that you are given, guys, you must be able to rewrite in the form where we are going to have these powers, x to the power of this. So let's start. 1 over x squared is not yet in that format. So what are we going to do? From our laws of exponents, this can be taken up, but it must carry a negative exponent. The square root of x from our laws of exponents, again, that is x to the exponent of a half. We are still just rewriting to have the format x raised to a certain power. That is the condition. Once that is appear, or once we see that, we can differentiate now. We have got the powers affecting x. So let's differentiate. The derivative of y with respect to x is going to be what? There is a 1, so we're going to multiply Remember the concept, -2 and 1. So that will give us a -2. Then we subtract 1 on the exponent, a -1 there, -1, a -2, -1, that is a -3. We drop the exponent here, then we subtract a 1. There's a 1 there. So you're going to multiply 1/2 times a 1. That's a half. So that's 1/2 x to the exponent of what? You subtract a 1 there. That's a -1/2. -1/2. 3x, that's a linear term, ax. So the derivative there, there is supposed to give us the coefficient of x, which is a 3. There we are done. We have differentiated. We are done. We have differentiated. We are done. But questions might be asked as giving your answer now. These are now different questions that you're now given. Giving your answer, maybe you're asked to give your answer as positive exponents. Give your answer as positive exponents. And in said form, where applicable, there we have to apply now the part of the condition that you're given. How can I make this to be positive? The negative exponent, so you take it down, -2 over x cubed from our laws of exponents. There is a negative exponent, so that'll be 1/2 is already in the denominator, so that's 2x to the exponent of a half. We are simply making negative exponents positive. After that, we check, is there a condition, is there a part that we can have the sets, because they're saying where applicable, we can write in set form. Yes, we have it. Remember that the exponent of a half, before it was the square root of x, and we write this as a half. So it's simply the reverse of what we had. So this will be 1/2, the square root of x plus a 3, just like that. So guys, as you can see, using the normal concept of your derivatives, you need the format, the standard form to use. Then from there, you can use those derivative concept from what we had. We need to consider the basic rule from y is equal to ax to the exponent of n. Then also the forms like when you can have a linear term and a constant, we can take advantage of that. That's a constant. The derivative there is going to be a 0. So there are so many different types of questions that we need to work with. And with time, we are going to come back with those typical questions, typical exam questions that you need to consider working with your calculus, which is the differential calculus.